Look down at the ground beneath your feet. We live on a quiet terrestrial rock where gravity holds us firmly in place. Water flows as a liquid, and the temperature is comfortably tuned to keep us alive. The physical laws of nature here feel incredibly reliable. Because this stable environment is the only reality we have ever known, we naturally assume that the rest of the cosmos plays by these exact same rules. But as we launch our instruments above the atmosphere and peer into the deep void, we find a reality that ignores our textbooks. Outside our thin atmosphere, the reliable rules of physics become increasingly fragile. Out there in the dark, the cosmos has forged extreme environments and bizarre anomalies that actively break our understanding of reality. When you realize that the physics we rely on is severely limited, the night sky stops looking like a peaceful canopy and starts looking like a highly volatile, completely unpredictable threat. Let's start with the basic rules of planetary construction. We're taught that water boils away if it gets too hot, and that every planet requires a host star to exist. Replace every atom of rock on a globe with water, and you get an ocean world. If you tried to sink to the bottom of one of these planets, the sunlight would disappear instantly. You would fall for days through pitch-black liquid, with the crushing pressure of several skyscrapers stacked on top of you. At those extreme depths, the sheer downward weight is so punishing, it crushes liquid water into solid ice even at boiling temperatures. This bizarre state, Ice 7, stays rock solid because pressure forces molecules to freeze, completely ignoring the intense heat. Remove the star entirely, and you get a rogue planet. These worlds were violently ejected from their solar systems and now drift completely alone through the freezing, empty space between galaxies. They reflect no light, meaning billions of them wander the pitch-black void completely invisible to us. The most extreme environment skips the star in favor of something much deadlier. Scientists now believe that the massive, violent rings of dust swirling around a black hole can forge tens of thousands of planets, creating what is known as a bliniment. Standing on the surface of one of these worlds, your entire sky would be dominated by a massive, light-consuming circle of nothingness. The only light comes from a halo of superheated gas screaming around the void's edge. Shift your orbit even a fraction, and you are swallowed alive. These worlds prove that planets are routinely forged by the most hostile, violent environments in existence. Moving beyond planets, we assume energy has a strict speed and travel limit across the vacuum, and we know that a star can only explode and die a single time. On a quiet night in 1991, a detector in Utah picked up a single particle smaller than an atom streaking through the atmosphere. It was carrying millions of times more energy than particles achieve at the most powerful accelerators ever built by humans. The GKZL limit dictates that cosmic background radiation acts like friction, stripping a traveling particle's energy. Yet this speck hit us completely intact, bypassing that limit. It was fire from an unknown source so unimaginably powerful, nothing in our galaxy could have produced it. Far beyond our galaxy, we also found a star that refuses to die. Usually, a supernova flares up brightly for a few months and then fades into the dark. But astronomers watched one specific star erupt, dim, and then erupt again, repeating the cycle at least 5 times over 2 years. The mystery deepened when researchers checked archival photographs of that exact spot in space. They realized this very same star had actually exploded 60 years earlier and somehow survived the massive blast, defying the rule that the sheer force of a supernova should destroy a star completely. On a much larger scale, look at the galaxy Abell 2261. It possesses the largest galactic core ever observed, meaning it should contain the largest supermassive black hole ever recorded. But when telescopes scanned the center, they found absolutely nothing. The black hole is missing. The leading theory suggests that during a massive galactic merger, an uneven release of gravitational waves acted like a cosmic slingshot. It physically kicked a massive black hole, weighing billions of times more than our Sun, completely out of its own galaxy, sending it flying blind into the empty void. From microscopic specks of impossible energy to rogue supermassive black holes, the cosmos constantly defies the limits we try to place on mass, power, and mortality. There is one final comforting rule we rely on: the belief that the empty vacuum of space is stable and truly empty. In reality, empty space is filled with invisible energy fields. The most important is the Higgs field, which dictates the strict rules for chemistry, gives matter its mass, and tells atoms how to stick together. But our universe might be mathematically unstable. We currently sit at a specific energy level, but physicists fear we are resting on a false ledge. At a random moment, a quantum fluke could cause the Higgs field to drop into a lower energy state. This event, vacuum decay, creates an expanding bubble of altered reality, where physics instantly stop working, erasing the universe without warning. This is a legitimate mathematical concern. When researchers discovered the Higgs boson particle inside the Large Hadron Collider in 2012, they ran the numbers and realized our universe sits dangerously close to that ledge right now. The very foundational fabric of reality could rewrite itself and delete our existence in a fraction of a second, and we would never even see it coming. The universe operates as a chaotic, volatile laboratory, testing the absolute extremes of what is physically possible, totally indifferent to our comfort. Our scientific laws are reaching their current limits, forced to expand to account for the impossible objects we keep finding. We are building more sensitive eyes, like the James Webb Telescope, specifically to study these outliers. Each discovery pushes our mathematics into a truer and much stranger version of reality. We have only confirmed a tiny fraction of what the cosmos has built. The rest of it is still out there, waiting in the dark. Leave a like to let the algorithm know you survived this existential trip, and subscribe to join us as we journey further into the universe's weirdest horrors.